In this situation, we want to find any local extrema, intervals over which the function is increasing or decreasing. Here we have a polynomial function, y equals x to the fourth minus 10x squared plus 9. Let's begin by finding any critical points. So we know critical points, look for those horizontal tangents or possible values where the first derivative is undefined. So first derivative equals 4x cubed minus 20x. We'll set this thing equal to 0. And we can solve it. Looks like it's factorable. So we'll factor out of 4x, leaving us with x squared minus 5. Next, let's apply the zero product property. So we learned that x is 0. And x equals plus or minus the square root of 5. So now to help me stay organized, I'm going to use my first derivative and use the first derivative test, setting up a number line with test points at 0, negative square root of 5, and positive square root of 5. I know the square root of 5 is between 2 and 3, so in this case I'm going to choose negative 3 as my test point into the first derivative. So if we plug negative 3 into this first derivative function and look for the output here, we have negative 3 cubed times 4 minus 20 times a negative 3. That's going to give us a negative output. So I know that I'm going to be decreasing over that interval. From negative square root of 5 to 0, I'm going to pick x equals negative 1. Again, plugging that into the first derivative, the output is positive. Plugging in x equals 1, output is negative. And my last test point, I'll choose 10. And this output is also positive. Now, based on that chart, anytime that the first derivative is negative, I know that f has to be decreasing. So I have my decreasing interval from negative infinity to negative square root of 5, as well as from 0 to the square root of 5. I am increasing from negative square root of 5 to 0, and from the square root of 5 to infinity. Now, by the first derivative test, from negative infinity to negative square root of 5, I'm decreasing, and then at negative square root of 5, I begin to increase. Therefore, I can conclude at that point, I must have a minimum value at x equals negative square root of 5. Next, I begin to increase and then decrease at 0. So we have a max at x equals 0. Next, we begin to decrease, and then we'll increase again at square root of 5. So I must have another minimum at square root of 5. Here are all my extrema and intervals of increase and decrease.